Today I'm going to talk to you about the benefits of VDI and implementation strategies for education. My name is Bill East. I work at Virginia Western Community College. I don't know how many of you are involved in education, but I sure hope a lot of you are since you're in my session. Oops, switched over there. I ride a motorcycle. I'm kind of a crazy little person. I like to ride motorcycles. Been riding for about 20 years. I also like to water ski. I got a little clip of that. Kind of show you some of the crazy side of me. That's a lot of fun. I also like to jump. But that's not all I do. I work as a manager of network services at a community college. I'm the manager of system support. I have a team of 3 engineers, 3 technicians, and 4 part-time student assistants. Can I see a show of hands of how many people actually work in a college environment? Okay, great. Awesome. All right. At our college, we have 3,500 students. We're one of 23 colleges that are in the Virginia Community College system, which comprises a student environment of almost 350,000 students. All put together, it's really the largest community college system, or the largest college system in the state of Virginia. We all have individual campuses with sub-campuses, so that creates kind of an issue where we all have our own little kingdoms and our worlds that we do things in. We have a lot of responsibilities with a very small staff. We manage email, phones, networks. We have 1,000 systems, basically a mix of laptops, desktops. We have 100 servers, a campus alert system. I'm sure many of you have to deal with campus alerts now since we've had some campus tragedies. We have a small staff, a lot of responsibilities. Basically, over time, as the funding model has become shorter, we've had to do more and more with less staff. And information systems seem to be growing, not shrinking. So what's new? You all know this. I'm sure you're all dealing with the same types of problems on your campuses. So what I'm going to try to do today is identify some of the challenges managing the educational environment. Throw out there some of the potential benefits of using desktop and application virtualization in the education area. We are doing that at our college. It is working. It's pretty handy. It's been kind of a challenge to get it going, but it does work. I do want to try to lay out some strategies here to overcome some of the obstacles that we went through when we started to do this at our campus and kind of give you a way to set some direction for implementation. By a show of hands, how many people here actually are doing desktop virtualization in one form or another for your campuses? Good. That's good. If you're not, you will. It's very powerful technology. So part of the challenges that we've dealt with is remote support. And for the faculty, our faculty members like to be able to work on things at home. They had VPN connections. VPN connections were a complete nightmare for us. We have open laptops, and that means administratively unlocked, so you install a VPN. You've got to deal with the complexities of teaching a person that's not necessarily the most effective computer user how to deal with a VPN. Why is it different when I'm on campus than when I'm not on campus? Pre-authentication, login, all kinds of crazy issues like that. Their job is to teach, not to have to learn how to use all the technology. Our labs were very difficult to support. We basically use an imaging process in the labs. We had remote labs. So every time we need to set software up at one of our 4 campuses, we would need to have someone go out, image a lab. And last-minute changes were a nightmare with that. Of course, with students' computers, there's so many different flavors of a student computer, and there's so many different things they can do to them. If you touch a student's computer, you basically own it. If you've installed their software on it, the next thing you know, they have a problem. They think it was something you did. Who knows who caused the problem, but someone's got to be blamed for it. In the world of IT, the word blame, I like to make it a two-syllable word, be lame. People tend to want to blame and find somebody to hang it on. We had 2 faculty at one site that needed access to a shared drive. Those 2 faculty were chefs. How do you get them access to a server that is back on your own campus with a VPN? Teach them how to use a VPN when their primary concern is basically teaching kids how to cook. They don't want to have to deal with the technology. They're not very patient when it comes to that. We had a lot of issues with software tracking and license compliance. How many licenses do you have? Where are they? Who installed them? Who bought it? With unlocked systems, anyone can install anything they want. And we had a small staff. How do you get somebody dedicated just to track all the software that's been bought, all the renewals, make a spreadsheet, even know who has it? Of course, we had the wonderful fun of unlocked systems. Everybody wants to be a power user, especially IT faculty. Why am I not a power user? I should be a power user. I'm smart. I know how to do this. They're one of the ones who tend to get their machines infected with malware the most. We have to reimage their machines all the time. That's a very time-consuming process when you have 3 technicians and 1 supports labs, and we're constantly reimaging machines. Application software delivery was a pain every semester cycle. We would have to deal with making a list of all the software that's needed in all the rooms. It was inflexible. The scheduling was a nightmare to try to figure out what was going to be in what room, and then the class sizes would not fit in the room, and all the different divisions would be putting in their information and their input. Basically making it a deadline operation. If it's not in by this time, we absolutely have to have it. The labs are imaged, you're done. And then, of course, they would go back to their division chairman and complain that we weren't flexible enough for them. Hardware and OS incompatibilities. If you wanted to run Windows 7 in a lab and you didn't have the right hardware for it, you only had the hardware for XP, that created a lot of challenges for us. We had Mac labs that we could not use to teach Windows classes. And then basically the last item here is the personal computer model. Application OS and data entanglement. People with a laptop, people with a desktop, not storing information in proper places. I need it to be on the network drive. My machine's corrupted. What I need you to do is let a technician spend 3 or 4 hours trying to figure out how to get my data off the drive that I shouldn't have put on there, but I need it. I really need it bad. And by the way, I have class tomorrow, and I'm going to go cry and whine if I don't get what I want. I need it tomorrow. Just fix it. I'm sorry I did this, but it's your problem now. So, does anybody out there identify with that? I see some smiles on some faces. Obviously, we do. How did we go back here? Okay, so the solution, and I put solution in quotation marks here, was to virtualize the systems, deploy them as needed, provide packaged applications, create a dynamic a la carte environment. We saw an opportunity to use VDI as a single source solution. We already had ESX server. We had VMware in place. We had been doing some virtualization of just one-to-ones, and we saw that we could use View to hopefully be able to provide the virtual machines, install clients, and let people have these machines to do what they needed to do and not cause us so many headaches. We thought we could provide multiple machines and not have this resource drain. People would want to have more than one machine. If they wanted to have more than one machine, they could have multiple machines, and they're all virtual. It's no big deal. You just present them to them through the interface. It worked on the servers, so we knew that it would be able to work on the desktops. It's just the technology wasn't there for brokering. We wanted to package all the apps that we possibly could. Application installation was a painful process for us. Packaging the apps and being able to stream them to the desktop seemed like it would be very handy. So we wanted to try to find some new tools to be able to do this. We didn't want to have to re-image people's desktops. We'd like to be able to do a refresh on the desktops. View offered us the ability to refresh the desktop, restore their operating system if they had a malware experience, and get them back working quickly. We wanted to have a standard computer configuration for them that if they could have custom machines, that's fine, but you've got a standard one. It's got your email. It's got everything you need in it. That machine is basically locked. You can use it every day. It lessens the emergencies, and that's one of the things we were trying to do was cut down on the number of emergencies that we had. The last thing was to separate the operating system, the data, and the applications. I talked about that, getting things into a mode that they live in different places, conditioning people that don't worry about the computer you're using. You just need to know where your data is. As long as you've got your data there and I can send you your application, I can give you multiple computers and you'll have the same access. Map drives, these kind of things. We typically use an iDrive. That iDrive is the individual my drive. I is you. Store your stuff on your iDrive. We also redirect the My Documents folder. So you could move over to Windows 7, log in. You're using a Windows 7 machine, and you still have access to the same items that you had, and it makes training a lot easier. So we thought, hey, this would be a great thing. Let's go ahead and just jump right in and knock it out. Come on now. All right. Well, it seems like my slide doesn't want to advance for me. We had some problems with my presentation earlier. Speaker Services did quite a bit of work for me. Apparently, it's locked up. Maybe it's a virtual machine. All right. Let's see. Let's get back to the solution. Go to this expected benefits. Okay, so for the expected benefits, we were looking at flexibility with this. We wanted to be able to give the faculty a working system and test systems without having multiple computers and let them use a connection broker to get to those from home, be able to also get to the same machine on campus. We wanted to be able to give them anywhere access and also provide virtual machines for our adjunct faculty. We have approximately 800 adjunct faculty, and we could not provide 800 computers for them to use. That'd be $800,000 worth of laptops, and our college just could not afford to do that. However, they could use their own computer from home and get to a standardized platform. We wanted to be able to install and remove software at will, and this was one of the most powerful features of View and ThinApp. To be able to tie this to Active Directory, use Active Directory memberships, Desktop Authority, or some other scripting program, and tie the software to their group membership was very powerful. Creating the group memberships based on an application like Firefox, allowing the help desk to make a person a member of a certain Firefox package that we built a special way, drop them in, now they have it. Log in, log out, it streams to their machine. No one has to get onto their machine and install or uninstall software. Typically what we were dealing with was people unlocking the machine, let us install our software the way we want, then have 15 different versions of the way they installed it, all the different possible choices. We didn't have to deal with that anymore. We could just give them the stream package software. The other thing was keeping account of the software that we had. In order to keep account of the software, we could have a directory membership, count the number of members in the group. We have 50 copies of this version of Adobe. There it is. It's 50 copies. That's all anybody has. We wanted to show the differences in instructional capacity, accessing one operating system from the next, to allow people to use an XP machine and use a virtual Windows 7 machine. They could log in. We could train them at their own pace. We didn't necessarily have to go and make the cutover. Every day they used Windows 7 machines if they wanted to, but basically they were standardized on XP. That is working. We do have Windows 7 machines functional in that capacity right now. The other thing was to be able to use the student identity to deliver applications, and I'll talk to that point a little bit later in the presentation. We wanted to reduce or eliminate the imaging process. Every semester we went through the same painful process of imaging and freezing machines. At the end of a class, the machine needs to be back in 5 minutes, exactly the way it was before. We used a product by Phoronix called Deep Freeze in order to do that. That was a very time-consuming process. It was a manual process, and we had one technician that would have to use student workers to go follow all the machines, make the changes, image the labs every semester in a very short time window. We wanted to make better use of the hardware. We have, in the virtual computer model, the compute is in the data center, not on the desktop. When the compute is on the desktop, every machine is wasting time, wasting CPU time, wasting power when people aren't using it. When it's back in the data center, that shared resource is not out on the desktops anymore. You can use thin clients. You can use a small, thin PC instead of something that has tons of memory. So that's a lot better use of the hardware. The soft client, being able to use old laptops with the soft client was also another angle that we considered. We had a lot of old laptops that can really run the software, the newer software in the virtual machine. But we didn't have to use it. We didn't have to surplus those machines right away. We wanted to get the very longest bit of life out of them, and we could basically turn them into throwaways at the end of the process. So was it too good to be true? That was the first question out of our mouths when we started thinking about how easy it was, especially from the sales angle. Salespeople tell you can do anything. But in reality, how many people do you have? How much fear do you have over it? And in my world, the FUD factor of fear, uncertainty, and doubt was very challenging to overcome. The risk-taking component. Can we take the risk? How much money is this going to take? Can we get out there on a limb and do what we think that we think is going to solve all our problems, and then end up creating more problems for ourselves? I water ski. I jump off the docks. I ride a motorcycle. I'm a risk taker, but I don't want to crash. I don't want to break my neck. I don't want to hurt myself. So we wanted to try to figure out a way that we could calculate this risk and get a conceptual model. How can we sell this to our administration? How can we even know what it will do for us? So when we started thinking about all those things, first thing that came to mind was how many hosts do we need? How many VMs will reside on each host? There was a lot of information on the web, a lot of studies on that, but we didn't know it was practical. What we wanted to try to do was just develop a model ourselves and see what it would run like in our own environment. How will they perform? Would it be slow? Would the graphics be bad? We heard a lot of rumors about how bad the graphics were, how certain programs wouldn't run. How will we deliver software? Will we just install it in the machines? Does ThinApp really work? How does ThinApp work? We don't have anybody on staff that even knows how to use it. What do we want to use for the hosts? We have a number of vendors, Dell, HP. Do you want to use blade servers? Do you want to use high-density servers? Do you want to scale this thing off of one large server or have multiple servers? How do we design all of it? How much is it going to cost? How much impact is this going to have on our data center? When we move the compute off the desktop into a computer room, what's this going to do for us? And it was just a question after question after question. We all struggled with those questions and tried to figure out how we would address these. So what we did is came up with a mind mapping technique. I found this was an old technique that was in a project management guide. And basically what you do is you start with the center and you work your way out. You have the center objective, which was desktop virtualization. And you work your way out with the larger details. Where would this be applicable? What would the data center impact be? As we moved around the circle in the model, we decided that we'd have to drill down, use the smaller, examine the smaller details from the larger bullet point. As far as the data center impact, when we move these workstations or we move these servers inside, how much power would we need? How much cooling would we need? How much space did we have? Those are critical things to consider when you're going to do this. When you look at the application of this, just in the academic world, we're talking about the reduction of software licenses, software availability, simplifying the semester changes, saving energy, particularly using thin clients on the desktops. Could we offer more classes? Could we offer classes as distance classes? Could these people run these machines or run these sessions at home where they have enough bandwidth? Could we support more labs this way at remote sites? Would it help us with last-minute changes? Could we have larger class sizes just by jumping from one room to another that had the thin client or the software, or the soft client software installed? So the mind mapping technique basically helps you eat the elephant. This thing is so large and it was so much to get our minds around that we decided that we would just break it into small chunks, examine it out into a larger picture, and start addressing things on individual levels. As we approached this, we understood that we were going to have to develop a pilot and on our own terms determine how many machines we felt could be used on this. We had been using HP servers, so we bought a couple of DL380s. They worked fine for us. We had about 75 servers that were running on HP DL380s. So we just used the same model that we were using the servers for virtual servers to do the workstations with. We bought these with local storage just to see how it would work. We didn't have the SAN connectivity for them at the time, although we had EMC SANs, and we used EMC SANs to back-end all the other virtual servers that we had. We proposed 200 clients. Initially, we really were seriously thinking of 60 per, and then if that worked out, buy the back-end storage and try this on 200 clients. Maybe do it out of the labs, do it for our admin desktops. We were moving to Windows 7 so we could run XP virtual machines out of our Windows 7 machines. We looked at buying 5 servers to do the hardware for the production system with Fibre Channel and use the existing EMC SAN, although we had discussed with NetApp buying a filer that could integrate the EMC SAN and get something that was NFS capable. If everything took off and would work properly, we would roll with that on the second phase. So part of the challenge was to get management to give us the money. The first part of the pilot was pretty easy. The servers were probably $13,000 a piece. We filled them up with storage, with hard drives and memory. And we bought the software for the ESX software, and we bought the pilot software for View. Initially, we created pools of the XP VMs. Just using our standard desktop image, we P2V'd what we were already putting on everybody's machines. And we fired it up, created pools of 30 machines to do that with, and we let people log into it, and just a small pilot group in our work area, and it worked. We tested refresh, we tested all the different functionality of it, and this was all done with View 3. It actually worked really well, and we found that the virtual machines actually performed better than physical machines with less memory. So we got some thin clients, we got some laptops, we took reprovisioned desktops, we did everything we could, tried different setups on those to see how well they worked, and we were very pleased with the results. I tested it from my house, just using a slow Cox cable connection, and it worked fine. So we started thinking that this was going to be a pretty good deal. We had very good results with the testing, and about the time all that came out, the H1N1 threat was apparent. It was perfect timing for us. We went to administration, and everyone had a major freak out over H1N1. What are we going to do if there's an outbreak in the schools and no one can work? How can somebody process payroll? How can we get our jobs done? How long is this going to last? We already had everything set up. So we just basically sat down the administration and said, look, we've already got a solution for this. We outfitted a couple of carts full of laptops with the View client, and we passed them out and let everybody log into the virtual desktops. It was their profiles and everything came in just like they normally did with XP, and the only things that weren't there were their personal customizations, but we already had my documents in the right place. They could get to all their files, they could print, and they were very pleased with it. And the machines ran 30 hosts with local storage without a problem. So that kind of gave us a model to work off of, that if we had one server, 30 hosts, how would it work if we had a more powerful server, back-end network storage? So we felt pretty comfortable in going to administration and showing them the potential of this. If you don't have the shared storage, though, you don't have VMotion, you don't have high availability. And that's another element of this that's really important when you move into the next level of the system. So for the next phase, we decided to go with the production model. We moved up in servers. We decided that we were going to go with the HP DL380 G6. One of the things that we also decided was we were going to move to the NetApp 3140 filer and use NFS as opposed to fiber channel. Just buy network cards to put in the servers rather than buy the HBAs. We already had the investment in the fiber channel, and we wanted to connect the NetApp system in. So it was really a good thing with the V3140 filer. It's a multi-protocol filer. You can tie the EMC storage in, manage it through APIs over top, and only have one system to manage through the NetApp. So that was very appealing for us. We bought a number of UPS systems. We already had a generator. That's one of the things you really need to consider when you do this, is that you got to have UPS power, and you should really have generator power or something to keep your system up all the time. You're basically rebuilding a mainframe. And when you do that and you move all the compute to the data center, you have to consider that this is going to be a mainframe, only it's basically made of components. We had a lot of drawings and discussions. We basically used a whiteboard, drew a lot of things out. We went back to our mind map, and we looked at what we knew from our pilot, and we started building this thing, and I kind of started getting an idea that I was going to present it as a foundation. Like the model was basically like building a skyscraper. We had a big hole in the ground to dig. We had a lot of work to do on the foundation before we could build the top end of it. We were going to need money for it, and that looked like it was going to be about $350,000. People freak out when you want $350,000. Okay, and so what I basically did is went to them and I said, look, you've got 6-7-year-old desktops. They're $1,000 a piece. You've got 800 of them. So you're going to spend $800,000 one way or another. My proposal is that we build a foundation to move towards the future, take 1/3 of that money, and start building this in a virtual world rather than in a physical world. This process of continually replacing desktops is a large waste of money. It's a waste of time. You've got people that are using machines to surf and email that really don't need anything that's very powerful. Most of our people do web surfing, emailing, and document processing. We started thinking about how much labor this was going to take. That was a pretty daunting part because we were already functioning in a world where our resources were stretched, and we're going to do a new thing at the same time we're doing the old thing. So I told them in the administration that we were looking at 800 academic and administrative desktops that were going to be possibly replaced by VDI. I did a presentation on this, and that was pretty important because after we did a lot of the work and got the first group of funds, they forgot how much it was going to cost to replace all the desktops. So what they expected was $350,000, and isn't this all done yet? I thought that's what you were going to do, is replace all the desktops. And I had to refer back to my presentation and explain that, no, that was the first phase of this. It's almost like building a house. And we got the foundation built, and we started to come out of the ground, and they were expecting everything to be paid for at that point. Kind of a selective memory issue. So we had a conceptual design. I got a couple of drawings here for the conceptual design. I apologize for being nervous. This is the second time that I've gotten up in front of people and spoken like this. This is really not my thing. I didn't even know this was going to be accepted, but it was. I'm here, and obviously so are you, so you've got some interest in it. It's a big thing. I think it's going to take off, and I think we're all going to be doing this. So I'm going to roll on here. We, like I said, we did the foundation-based proposal. I did show that to the administration. They bought into it, foolishly or not, will remain to be seen. So I'll give you an idea of what the authentication model is like. I don't know how many people here actually know about View 4 or have actually done any reading on it. Looked at the manuals, just show of hands maybe. Okay. Well, quickly, the home or the mobile user comes in from the internet. We have desktop.virginiawestern.edu as our URL. You come in, you hit the security server. It speaks to the connection broker. It says, who are you? Depending on your identity, if you're local, it will look you up in a local database. We have everything tied to Active Directory, so it's all single sign-on. It also can tie back to LDAP. One of the challenges we have right now in the student world is we do not have an Active Directory for all of our students. It would be real nice to have 350,000 students in Active Directory. What we have is an LDAP directory of 350,000 students. And LDAP does not like to log into Windows. So how do you get that to work? You write a GINA, change the GINA. I don't want to change Windows. I want to give Windows the right information. So if anybody knows how to port the LDAP into Active Directory, talk to me after this, because there's a big job that's coming up that someone's consulting company could probably get. Anyway, once the user's credentials are verified, the connection broker looks at their entitlement and decides which virtual machine they're allowed to get. Actually, which or any number of virtual machines. They could have a whole list of machines, and their Active Directory credentials could be used to tell what class they're in, what virtual machine you need, what software is in that virtual machine. And as I understand it in View 4, or View 4.5, they will be linking ThinApp applications into the same thing. So that's really cool. I know who you are, and you need these things. And I can make you a member of that group and pass that down to you. Our entitlements are linked to group memberships. The integration with Active Directory is very handy. It's a single source solution. That's another thing that we really liked about it. We had people from Citrix trying to get us to buy into this, and I like this because I was trying to keep it simple. For the on-campus user, actually, let me explain this too. From home, the experience is the same as it is from on-campus. So if a person takes their laptop home and they hit desktop.virginiawestern.edu with the full client, they have pass-through with USB. Their drives are all mapped. They can copy files back and forth. They can print. There's no VPN. It's exactly the same as it is on campus. That is using the RDP component of it. PCoIP does not traverse a firewall, so you have to have a VPN for PCoIP. The thing that really impressed me with it is it's the same experience in either place. It makes it simpler for the people. In the labs or the faculty on campus, hit the connection broker and go straight to their virtual machines. But it looks the same anywhere they are, so there's no VPN, and that was huge. Once they hit their virtual machine, that virtual machine is living inside of my infrastructure, so they're carrying nothing off of the campus. The virtual machine is given map drives. It's given connectivity to our intranet, which basically we have a SharePoint site. What initially, when we did not have virtual machines, everybody wanted access to the internal SharePoint. I did not want to put the SharePoint out on the web. I wanted to leave the SharePoint inside and make the security simple. You just come through that one hole. That's where you get all your machine is inside. I don't want to have to deal with opening the firewall and managing the firewall. Our firewall has 7 contexts, and there's probably 10 DMZs in every context. It's incredibly painful to manage it. But the security model is very good in the way that it's set up. My security engineer's pretty much a genius. So in phase 1, we decided we were going to build the foundation. And the way I explained it to my administration was the foundation takes the longest time and you see the least. We're digging a hole in the ground. We're building all this stuff. You're not going to see things happen. It's going to take a while to get it out of the ground. It's just like when you build a house. When you get the thing out of the ground, you have to have a good solid foundation in order to build the stories and stack up on top of it. And I've got another diagram to show that. We bought 5 HP DL380 G6 servers with 64 gig, just dual quad-core processors. We didn't buy these monstrous machines. And they actually run great. And we can run 40 VMs, 50 VMs on those, and they're sleeping. They work really well. As part of this project, since we were already mostly an HP shop, we talked to HP, and I worked with one of my VARs, and we got a deal worked out with HP where they donated labor. And we used that labor towards thin apping. As an educational entity, you have a lot of power. If you can talk to the VARs and talk to the vendors, they want you to get this stuff implemented because it sells their product. And HP was very generous in giving us money, and I have to thank them very much for that. We've been using HP servers for about 16 years. I'll give a great plug to them. They have been rock solid. I can't say anything, not one single thing bad about our experience with HP. We bought a NetApp V3140 storage system. That was a big stretch. It was quite expensive, but that's the core of the foundation. It is very strong, and we haven't had any problems out of it. It's very responsive. That system coincided with us getting several EMC SANs donated to us. And they were fiber channel SANs, so that was really a stroke of luck because we could take the EMC SANs, manage them with the NetApp system. It has a multi-protocol filer. Some of the benefits were it had NFS storage. We could use NFS rather than fiber channel. We didn't have to deal with the fiber channel switches, the LUN locking, and all the other issues that you deal with fiber channel. NFS is pretty straightforward, and it's fairly simple in terms of, well, as far as simple as it can be in this world. We had Cisco infrastructure, and the NetApp storage system was tied into the Cisco infrastructure. One of the things that we did was when we moved to the Cisco NetApp, got away from fiber channel, we created our own storage network, our own storage VLANs. You're going to need to do that. The VMotion network basically ties back to that same storage system and that same storage network. It's just like a network. It's basically like an HBA. That's the way I thought of it. It's just you're building your own network there. It's a little bit simpler. And the performance of it is really good. We did have some problems in the beginning. We set up some trunking on a blade that had too many VLANs on it, and we brought the whole network down as a process of that. And when you enter a command and all the lights go off on the phones, you know it's a bad day in the middle of the day. We have a Cisco 6513 switch, and it blew its mind. And basically, it went into a spanning tree loop and had to be powered off and restarted to get it back on track again. NFS does work. CIFS works. The biggest challenge that we had was the bomb. When the storage is cut off from the virtual machines, they are not happy. Their head has been chopped off. So basically, we decided at that point what we were going to do was create a secondary network just using a couple of gig switches and set up fault tolerance failover so you could shut the core down and all the virtual machines would still have connectivity to their storage. We did that, tested it, and it did work. So this picture here basically depicts the model that we worked off of. The NetApp filer is over here. It had 8 Ethernet connections to the 6513 core. We connected from the core into a bank of the ESX hosts. and it basically would add ESX hosts to let the system continue to scale, knowing that we would be building the foundation with this part right here. All the blue items were the foundation items. You can see the round circles indicate the virtual machines. We had a virtual View 4 connection broker, virtual security server, and then we have pools of the academic machines on the other side. We use no physical machines in this. So basically for phase 2 and beyond, the way we built this, we could just continue to add servers. I've got a picture in here of our server farm. Starting with the 5 times 4 was 200. That was the first proposed group of clients. We basically just add a couple of servers, and as this thing grows, we just add more servers. One of the challenges with the servers and that we had experienced in the past was when a server got old, how do you replace it? How do you get it out of the loop? And that's the beauty of ESX. You can basically just throw that guy over in maintenance mode, and all his VMs will scurry over to another machine. You can pull him out, stick another one in the cluster. The same things that make ESX work make this work. All the back end is very powerful, and it's already fully baked. The high availability is really good because we are using the DL380s as blades, as processors. You're just sticking another DL in the box, adding it to the pile, adding more power. You can add load balancers to this if you need it. At this point in time, we have one security server, one connection broker, and we haven't had any issues with it. We're probably running 200 VMs, seriously. It's not as big as I'd wanted it to be at this point in time. We have an emergency announcement system that came in that my engineers got pulled off of that we had to get installed this summer, and that took a lot of the time that we were planning on getting this in. But we do have at least 140 virtual machines that are being used by faculty now that are used on a regular basis. In production now, we have 8 clustered high availability servers. We increased the memory in those, and they're the 380 G6s. They have 128 gig of memory, and we did NFS connect them to the NetApp Storage. It seems to be working really well. We haven't seen any problems at all with it. The pools do float, so if one server gets busy, he just moves over things that are not busy to the next machines. If you think about it, you've got library reference systems. You have a lot of machines that really just don't use much horsepower. So you're taking all this compute off of the desktop, putting it back in the data center, and letting the system handle what needs the processor time. It is built on VSphere, and it works great with that. We have, like I showed you before, we had the 8 times 50 for the number of clients possible for 400. I think that is feasible. And we're running XP and Windows 7 32-bit systems. Being able to have the Windows 7 systems out there for the faculty was a very nice thing. When they start pressuring us, they want something. They go over our heads with administration. They start asking for it. That's what they got to have. Then it comes down to us that that's what you're going to give them. So what we try to do is anticipate on the bottom side of it, put the machines out there ahead of time, and let them start playing with it. We don't have Windows 7 in all of our labs. We never used Windows Vista. I don't know how many people here deployed Vista in all their labs. Well, that's a joke, right? Anyway. That's actually what the hardware looks like behind the racks and in front of it. We have 100 servers running on this cluster of HP servers. That's the NetApp system in the middle, and the EMC storage cabinets are down below. You can see the UPS systems here, and this is the stack of the DL380 G6 servers. You can see how much space this actually takes. It's only 3 racks. So when people try to sell you blades, You need to think about how much is your space worth. I mean, in my opinion, when we did evaluations on blades cost 2 times as much as those boxes did. If space is not that tight for you, go ahead and do it this way. We set up a hot aisle, cold aisle system, basically with the floor in front of these has air conditioning that's blowing up out of the floor, and it blows through the servers and then comes out on the back and goes back to an air system. They get very hot. If you want to warm up in the wintertime, stand behind the server rack. It's very hot. But and that's another thing that you've got to consider when you do this. If it's in the data center, you've got to have the air conditioning. We had some issues with this, with our air conditioning system, and we had to put environmental monitoring and things like that back in place. I was fortunate enough to work at this college 21 years ago when they had a mainframe in the data room. So the mainframe all got pulled out, and we've basically rebuilt the mainframe in these racks of telco racks. All the cabling and all the stuff back in behind is color-coded, and we did that just to basically see what was NetApp Storage, NFS, what is network connections. It's fairly neat. I mean, in a community college environment, you have limitations on funds, and it's not a commercial production data center like you'd see in a hospital or something like that. So today, some of the benefits that we've realized, we have distance learning and hybrid classes that are using VMs right now. We give a virtual machine to an instructor, and we tell them, set it up the way you want, and we broker that to them. Once they've got it the way they want, they'll tell us, and then we clone it and hand it out and set it up for their classes. It's very simple to administer this. The View admin console is managed basically by my engineering group, and they're the same guys that are LAN admins. We have an application delivery model that's hybrid. ThinApp is really cool. It works. You need to get somebody trained on it. It takes a little while to get your hands around how it works. I just ate lunch with one of the ThinApp development people, and he explained some concepts that they have brewing on that are going to make it a lot easier in that respect. You don't have to be a computer scientist to package applications. That's one thing that's very nice about it. We have a lot of apps packaged already, and they are deployed with Active Directory or shares on NetApp CIFS. We just basically can tell somebody, here's where this app is, make them a shortcut. ThinReg is one of the key pieces of this that you can run a batch file, ThinReg it goes into the registry, it puts an overlay in the registry and sets up the file associations and everything you need for that application to be in the start menu. You can put it on their desktop. It's very flexible in that respect. And it's very convenient when somebody calls and says, did you hear we've got a new version of Blackboard, and the distance learning people just told everybody that they need to have Firefox with these plugins. And so they all want to have their machines unlocked so they can install it. And it needs to be done like today. So just what should we do? And that's the typical call I get. What should we do? Should we unlock machines? Should we enter a work ticket for all of these? Communication is one thing that is lacking a lot of times. So for us, all we did was slip over in the back and go, make faculty and staff group a member of Firefox. Tell them to log out and log back in. And it's fixed it for the whole campus. I'm like, wow, this is powerful. From home, the browser access is primarily done for students, but we also will give them the full client. I will say this much, we have seen a couple of instances where the local machine can have an effect on the virtual machine. I thought it was completely isolated. It's not absolutely and completely isolated, but that's pretty rare. I don't want to own a student machine. I don't want to touch a student machine. I don't want to troubleshoot a student machine. Our faculty that teach distance classes don't want to touch a student machine. One of the biggest things they like about this is not having to install software for the students or provide the software to the student. All we have to do is just give them the client, and they can put it on, and that's all they need. Our help desk extended their hours, and we have distance classes, and we have bad weather in Virginia. So they can work from home, and they can use their virtual machines, and they can chat and do all their stuff that they want to do while they're at home when it's an inclement weather day. Our support does not stop on an inclement weather day for distance learning students, and our distance learning student pool is growing. So that's very handy. I talked to you about the faculty and staff and having the full on-campus experience. That is very important. We just rolled this out in the beginning of the summer, and in summer we don't have that many faculty. Once they saw it, they started biting on it. They really liked it. In the fall, we had training for people, and we started getting out there and having more people get on it. Started opening it up for the adjunct faculties. In our world, adjunct faculty have a secondary existence as far as they're concerned. They really feel left out. They're treated as second-class citizens. We don't have a computer. Nobody cares about us or whatever. So I wanted to be able to make them have a computer and have them have this access. And you know how it is, if you've ever touched, and I'm sure everybody in here has had their mom or their sister or a cousin or somebody get them to work on their computer for them. And once you touch their computer, you own it. It's remember when you put that hard drive in for me? One of the nice things about this is you don't have to touch anybody's computer. It's completely separate from that. You can build the computer the way you want it, and you can give it to them the way you want it. Users are accepting these. They're gaining dependence on them. I use it every single day with Windows XP. I don't even have an XP desktop, and I haven't had an XP desktop for probably a year and a half. It works great. The only things I see with it, I don't know. I don't really have any complaints myself, to tell you the truth. The PCoIP stuff is a little bit challenging, knowing where you are and making sure you've got the settings right. The dual monitors and those kind of things work. So some of the benefits on the other side is the VPN is gone. You need that for PCoIP. We have a Cisco ASA. We're setting that up to be able to have multimedia streamed. PCoIP works really, really well. On campus, it is banging. I mean, I've used it. I've watched videos on YouTube. I've compared the two back and forth, and it is very strong. If you have issues with your LAN, it might be some latency problems in it, but if you've got a good switched 100 meg LAN, it works really, really well. The academic labs, all of our labs now have the full client. So we're in a position where we can set up virtual machines, and if there's a last minute change, we've got faculty members that are willing to embrace using a virtual machine in there. I just checked my email this morning, and I think we had math type 9 or something that wasn't in the labs. Oh man, we got to have it in these labs. Emailed my guy and said, look, you need to put this in a virtual machine and let these guys be able to get this stuff in a virtual machine. They can get to it from anywhere. Who cares what lab it's in? That's the next phase of this for us. It definitely works that way. We are brokering special use VMs and physical systems for this. Okay, one of the things that I ran into is an energy management system that people from off campus needed. And they said, oh man, set us up where we can come inside and give us a VPN or whatever to be able to get to this. And we also want to have a web interface where we can manage it. I installed the VMware agent, brokered it with the view, gave them entitlements, created AD accounts for them, and all they got to do is have their account, come inside, and they get full access to that machine. So then they come to me and they said, my map drives don't work. Something's wrong. Something's wrong with this thing. It's not working like it's supposed to. Try it with my machine. Try it with my client. Works fine there. Try it with this other laptop. Works fine there. Try it on that machine from in the lab. Works fine there. Now go figure out what's wrong with your laptop. I don't have to figure out what's wrong with this machine. He knew that it was broken. So that's pretty strong. We do have Windows 7 machines available from XP systems. So on the training side, going through and doing a global Windows 7 migration is a lot easier because we can just gradually move people in offices that as they get trained. Training and scheduling is a pain to get everybody in classes. I know if you guys have had to deal with that before, it's a major hassle. Faculty don't want to come to training. Everybody already knows how to use it. So let those people that have the capability, go ahead and start using Windows 7. And have your classes for the ones that are slower rather than hold everybody back to that same slow standard of moving forward. Why haven't you gotten installed yet? Well, we can't train everybody. Our remote sites are much more supportable. Even the two chefs that I mentioned really like this stuff. They can get to their shared drive. It's simple. They don't want to have something that's complicated. The printing, thin print, and just normal printing, being able to print back on site works. We've had a lot of success with that. And if you can get your least skilled users to be able to use this, it saves a lot of time. Remote sites, the OS data and applications are diverging. That's really cool because once people start using the virtual machines and they're like, wow, this is just like my desktop. I still have my iDrive. My documents are still there. And then you give them more machines, they realize that, hey, I know where I've saved my stuff now. And that's part of the problem that we had to deal with, is people didn't have any idea where things were being saved. Now they do. And as long as they're storing them on the network, they can go to Windows 7 and, I still got the same files. Wow, I didn't know that. The iDrive is the iDrive. The big key for us is a reduced need to provide laptops to faculty. All of our distance people want to have a desktop and they want to have a laptop. They don't want to have to bring the laptop back and forth every single day. They want to have a desktop to be able to use at work, and then they want to have a laptop to use at home. Well, they've also got a home computer. So I can go to administration and say, hey, do we even need to provide a laptop for them at all? And if we do, does it have to be an $1,800 laptop that is a very high-end thing, or can we give them something light and small that just runs the client, and all they need to do is get to their virtual machine on the back end? And they don't have these arguments that I don't have enough processing power, it's too slow, and all that stuff. So some of the remaining challenges and issues, application packaging is still developing. It's still developing for us internally because we don't quite understand how all of it works. Everything is not suitable to be packaged. If you try to put Apple software on a package, there's some issues with that we've run into. I'm not going to be able to completely quantify that it's totally still developing, other than our guys are still developing and learning how to use it and how to package. Hopefully with 4.5, this stuff will get a little bit better. I also heard that 4.6 of ThinApp came out recently. Windows 7 support was an issue, and Office 2010 would not be packaged with View 4. With ThinApp 4.5. Supposedly it works with 4.6. So that's another good piece of it. One of the big things here, when we got into this thing, we were going to go to all thin clients. Well, what if you don't have a CD drive anymore? How are you going to deal with that? How are you going to deal with the acceptance of the change that people are dealing with? We did not go to a complete thin client model. I tried to sell that, and that was the beginning of this thing. Basically what we did was we went to a hybrid model. We needed to replace the old desktops, and we bought a HP 8000 that was an inexpensive desktop that was good enough to run XP, that will run Windows 7 in the data center with. It's a lot more energy efficient, and that's one of the things that we pushed with this was energy efficiency. It is a new computer for them, and it's something that looks like a thin client. And one of the things you got to remember is perception is a big thing. If people think it's a thin client because the computer is mounted on the back of the monitor and the stand, to them it is a thin client, even though it has a software client on it. So that was pretty handy. With the thin client itself, we're going to be using those in labs. I think that's a good use for it. And most people are storing things on USB sticks. So we really see that as being a big thing in the future. CDs and DVDs are not being used that much at my college. I don't know how much it's being used at yours, but we're not seeing that. Bandwidth offsite is a problem, and I'll explain that. The public internet is the unknown territory. So depending on what you've got, this does not work on dial-up. It doesn't work on poor connectivity. So if they're at home and they're having issues with it and the screen paints are in blocks and chunky, it's a bandwidth problem. It doesn't work here with all these people on this wireless system. I tried it from home, it's very slow. It'll let you log in, but it won't give you the machine. With firewalls, with PCoIP, you got to have a VPN. The user unfamiliarity thing is an issue. We've got the fear factor of it. It's different from what I'm used to. The other thing is Control-Alt-Insert. What's Control-Alt-Delete? You've got some things you've got to teach these folks here. Windows 7 support's a little thin, and that's something that we want to see get improved in the future. And I've already talked about the acceptance of the thin client in general. People are used to their computer. It's the way they've always done it. So when you tell them you're going to use a thin client, is that something that they're going to want to be doing? So the virtual desktops are the easy part of this thing. Anybody can do that. We've already done it. Application delivery is really the challenge. And I think with the next version of ThinApp coming out, and the things I've heard, it should be really good. With 4.5, that's another strong point with this. The virtual machines affected by host issues I mentioned. The networking is shared among the VMs. So when you're doing patching and you want to patch all the VMs at one time and you're not recomposing the core VM, things can get a little slow. How many network cards do you have in it? The compute's in the data center, so you got to be really careful about a single point of failure. If you have a problem in the data center, everybody's offline. So we went through and identified the challenges. I think I've demonstrated some of the potential for you guys. We've got the strategies out there that I laid a few of those out. I know you'll have plenty of challenges on your own. Any questions or comments? Yes? No, View will do that for you. It spawns the machines and it gives them their own names. It will do it automatically. You tell it the machine to make and the series to make through the View admin. Yes, it just appends the data and just makes more machines, however many you want. And you tell it to add to the pool and it will continue to add. Yes?
How many operational pools do you work with?
Thank you. Sorry, we're running over on time. I'm sorry.